is the difference between them?
The size.
Is size. The difference between them is size. So we can say now that the similar figure is, the similar figure is two figures, two or more figures, they have same what, but don't have same what. There anyone can fill the space in this sentence? Yes, Walid, Muhammad Walid, go on. Muhammad.
They are both have the same. They are both rectangles, but they are different in size.
Yes, both are rectangles, but they have different size. So if I want to fill the space in this sentence, so what I have to write here in this one, they have same what?
They have shape.
Yes, thank
Shape,
you.
but
Yes, they have
has a different size.
same shape, but they don't have same what?
Size.
Okay, then if we want to talk about the similar figure, so we can say that the similar figure, they have same shape but don't have same size. Okay, so this is apart from our topic today, which we want to talk about it, which is similar figure and scale drawing. So what's the meaning of a scale drawing? There, if I will ask you to draw your school,
It's gonna be it will be the opposite. They have the same size, but they don't have the same shape.
they have the same size. If we want to talk about a scale drawing, ya Muhammad, they have the same size. Let me say something, honey. If you want to draw your school in a small paper, what is the difference? If you want to draw your school in a small paper, you can draw your school or not?
Yes, but it will be small.
Yes, but it will be small. Very good. Then they have what? Then they have what?
Similar.
They are similar, right? They have the same shape, but they have different size, right? The real one is bigger than the drawing
The
one.
second one.
The drawing one, yes. So the school, the building of the school, it will be greater than the figure which I draw it in the paper. Let me ask you another question to all the class. If I want to draw an insect in a paper, if I want to draw an insect in a paper, how you will draw it? You can draw it or not? If I will ask you to draw a butterfly.
Yes.
Yes.
Yes, you can, right? And you are perfect.
Yes.
But what is the difference? What is the difference?
That it's gonna be bigger.
It's going to be bigger. Yes, yes. So for the scale drawing, sometimes we are going to draw the bigger, we have a relation between the map and what? And what? And the real. We have a relation between the map and the real. Okay, so if the original figure was greater than the drawing, so this is called shrinking, because the school was big and you drawing small. So it will be what? Reduction. So we have two words, we want to know them today. Enlargement and reduction. What is the difference between those two words? So we said that the scale drawing, it is a relation between map and real. Okay, the scale drawing, it is a relation between map and real. And we have two words now in front of us: enlargement and reduction. Is there anyone can tell me what is the difference between those two words? What is the difference between those two words? What is the enlargement and what is the reduction? In case we have, if you want to draw your, school in a paper, so this is reduction. If you want to draw the insect, so this is what? Enlargement, because the insect was very small and I want to make it bigger. Okay, so this is just an introduction about our lesson today. So let's watch a video together and then we will back to discuss with my lovely students. Is there any question before we will start? Any question before we will start? Okay. Let's watch this one. So we want to finding the dimensions.
Scale drawings to solve problems. And what even is a scale drawing? Well, scale drawings and scale models are used in map making, construction, and other trades. So what we're looking at here is a blueprint, and that's a technical drawing that usually displays architectural plans. Pete's blueprint shows a layout of a house. And let me zoom in on this. So every 4 inches in the blueprint represents 3.
So the blueprint now represent what? The layout of a house. Okay, then your house, we can make a blueprint like this. Okay, so we can draw it in a paper first, and after that, so the architecture, they draw it in a paper, and after that they will transfer the dimensions to be a real building. Okay, so between the map drawing, this one because he draw it in a map, and the real one, we have something called what? Scale drawing. So this is called what? Scale drawing. Understood this part, grade 7? Grade 7, could you please anyone tell me?
No, Miss, can you repeat it again?
Again, okay. In this one, you know the architecture, the engineering architecture?
Yes.
When he want to design a building, so he should draw it in a paper. Okay, if you look at the paper, you will find a dimension in this paper. Then we have a key for this paper to translate it into a real one. So first we will draw it in a paper, and then we are going to find the relation. Each 1 inch in this figure, it will be how many in reality? So for example, if this distance was 2, and he put for us a key that for each 1 inch represent 4 meter, then we will multiply each one by 4 to find the real dimensions.
3 feet in the actual house.
So in this one, he said 3 feet every 4 inches in the blueprint represent 3 feet in the actual house. Then for the map here, he represented by inches. Which is bigger, inch or feet?
Feet.
Which is bigger, inch or feet? Feet, right?
Feet.
So in a model, every 4 inch, it will be 3 feet in reality. Let's continue.
And so this right here, this looks like, this looks like there's a doorway into a bedroom, and here's a bathroom, and that looks like it could be a little kitchen, and these look like stairs here. So every 4 inches is 3 feet. So every 4 inches represents 3 feet.
So you can imagine that this one is your house.
That by 3, and that would tell you how many feet you have. So one of the walls of the blueprint is 24 inches long. So what is the actual length of the wall? Oh, I was wrong. Actually, you don't have to multiply by 4. But I'm going to show you what to do here. You don't have to multiply by 3. That was a little bit of a mistake. But here we go. So in this table, 4 inches represents 3 feet. So if I double this number, I would have to double this number. And that's an increase of 4. If I triple this number to 12, I would have to triple this number, which means multiply it by 3.
So in this case, grade 7, we have the blueprint length and we have the actual length. Okay, so for at the beginning, we have to find the relation between the map and the real. We have to find the relation between what? Map and the real. So if the map is 4-inch, represent 3 in the actual. What about if you will double the first one? It becomes 8, so we have to double. 3 becomes 6, right? Then if you will triple, so you have to triple. So the key is very important to transfer a model into actual. Okay?
If I quadruple, if I multiply this by 4, I get 16. If I multiply 3 by 4, I get 12. And if I multiply by 5, I get 20. By 5, I get 15. And by 6, I get 24. And by 6, I get 18. All the while, you are also, each time you add 4, you have to add 3. Okay, in this blueprint, sidewall is 16 inches long. And so, how many feet is that? Well, we can look here. 16 inches long is 12 feet. What you could also do is you can see 4/3 is our scale right here. And if I multiply 4 times 4 is 16, so I'd have to multiply 3 times 4, and that is our missing variable, 12. The back wall of the house is 33 feet long. So what is the length of the back wall? So this back wall is 33 feet, I believe. Or I'm sorry. Oh, the back wall is 33 feet. Yeah. So what is the length of the wall in the blueprint? Okay, so it should be 44 inches. So what I did here too is you might be wondering, well, how do I know where the X goes? Well, this stays the same. And the 4 is the inches, that's in the blueprint, and the feet is in the actual. Okay, so, and they even,
okay, grade 7. Now we know that the difference, there is a relation between the map and real, right? We said that there is a difference relation between map and real. Then I have here, he said that this is the map, right? And this is what the real. This one was inch, and this one was what? Feet. Then if you want to draw your building, your school, so if I will draw my school like this, the dimensions which I will draw it in the paper, it will be the same like the dimensions in actual? They will be the same, or there is a difference? If I want to draw my school in a paper, it will be the same like the dimensions in actual? Grade 7. Hello? Hello? Is this your school? If I will give a paper to everyone and I will ask him to draw his school. So he's going to draw exactly the same. It could be exactly the same shape, but it will not be the same what? Size, right? In the paper, for sure, the school, it will be smaller than the actual dimensions, right? So if I will give you a key and I will say that map to real, every 1 centimeter in the paper, it will be 2 meters in reality. Okay, then I will go to the school. We said if every 1 centimeter represent 2 meter in reality. The relation between map and real is called what? Is called scale drawing. It's called what, grade 7?
Scale drawing.
Scale drawing. So the relation between map and real is called scale drawing. Okay, then if I will come here and I will put 2 centimeter, that means if I will put here 2 centimeter, that means in reality it should be how many meter? Should be how many meter, grade 7? If I will draw here 2, so we started before the proportional,
Gonna be
right?
4.
It should be 4. So if this one is 2, so I can put it here and then I will make 2 times 2, then I have 4 meter, right? If I will change now, and I will say that this one is 8 centimeter. So if this one is 8 centimeters, so in reality, it should be what? In reality, it should be what? If this one was 8 centimeter. So in real, it should be, we will put 8 after the map here, 8. Okay, and I'm looking for the real one. So we will make 8 times 2, it will be equal 16. What about if this one was 10 centimeter? Huh? If it's 10 centimeter on the map, so it should be how many in reality? If this one was 10 centimeter on the map,
20.
it will be 20. How did you find it, Ya Muhammad?
We multiply, every 1 centimeter is 20 centimeter.
Every 1 centimeter is 2 meter, right?
Yeah, so it's gonna be 10 multiply 2, it will be 20 centimeter.
Excellent, Ya Muhammad, excellent. Then I said that there is a relation between map and real. For this reason, we have to back and search about the scale drawing. After that, this building, okay, it's drawing in the map, and this is called map. So I want to calculate the real one. So we will back to the scale drawing. We said that each 1 centimeter represent 2 meter, right? Then if I want to calculate what is the length for this door.
It is 4 meters.
Which one is 4 meter?
The 2 centimeter, it's 4
yes,
meters.
It's 2 centimeter, but the last question was 10, right? So if this one was 2, so the reality should be how many, Ahmed?
4 centimeter, 4 meters.
Very good. Right. If I will say that I have a part with 50 meter, if I have a part with 50 meter, so it will be how many?
25, Miss, I know, 25 centimeters.
25. Excellent, yeah, Ahmed, excellent. It will be 25. So, what the meaning of scale drawing, grade 7? What the meaning of scale drawing? It is a relation between what? Scale drawing, it is a relation between what, grade 7? A relation between map and real. It is a relation between map to real. Okay, and we can find it in different situations when we want to draw a figure from large to small or from small to large. Okay, let's continue.
Tell us right here, 4 inches in the blueprint, 3 feet actual. So that means that what we're trying to do, well, what we're given is 33 feet right there. So anything with feet would go into the denominator, anything with inches would go in the numerator. And we're trying to find the length of the blueprint, and so that's going to be in inches. So that tells us it's going to be in the numerator right there. 3 times 11 is 33, so
So we have today, as I said, vocabularies, which is drawing scale, which is scale, reduction, and enlargement. Okay, so today, inshallah, we have the scale. It is a relation between map to real, right? It is a relation between map to real. So the length of an object in a scale drawing is 2 centimeter to 8 meter, right? So we can use the ratio to represent the relation between them. 2 centimeter represent 8 meter. He said here, the scale is 1 centimeter to how many? So we want to find the answer in simplest form. Like what? Like 2 centimeter, 2 centimeter over 8 meter. If we have now, we want to write this one in simplest form. So it will be 1 centimeter over how many meter. So we can use cross product in this case. How? It will be 8 multiplied by 1, it will be equal 8, and x multiplied by 2, it will be equal 2x. What we have to do, we learned before how we can solve equation, right? We learned how we can solve the equation. 8 equal 2x, so we will divide it both by how many here to find the answer, grade 7? We will divide by how many? 8 equal 2x. How we can solve this equation? 2x equal 8. Huh? Yes, go on your word.
We will do 8 divided by 2, and
Yes,
it will
we will
be 8.
divide it both by 2, right? We will divide it both by 2. Then the answer, it will be how many? Then x equal 4. Then what is the scale in this question? The scale, it will be 1 centimeter to 4 meter. So in this question, he were asking about what is the scale. So we have to put the scale and want to simplify it. We can use another way from the beginning. We can write 2 centimeter over 8 centimeter. Both of them can divisible by 2. So we can say that we will divide it by 2 for the numerator and divide it by 2 for the denominator, right? Then the answer, it will be 1 to 4. So we have different ways to answer the same question. In this one, he's looking for the scale, and we have to put as a 1 unit. 1 centimeter represent how many meter? Understood this part? Understood this part?
Yes.
Let's move to the next part. Here, the length of an object on a scale drawing is 1.5 inches. The scale is 1 inch to 6 feet. What is the actual length in this object? Where we have to start with? We will start with the scale first. The key for the question is the scale. 1 inch represents 6 feet. So we will write it like this. 1 inch, 6 feet. And then in this question, he gave us the map or the actual. When you read the question here, Gasser, where are you? Gasser. Abdurrahman Subh. Ruqayya.
Yes.
Yes.
I'm here.
Okay, where is the scale in this question? We said that the scale, it is a relation between map and real, right? So
Yes.
which one represent map and which one represent real in this scale?
1.6 represent
Where is 1.6, ya Abdurrahman? Where is 1.6?
1 in
Inch. This is 1 inch.
1 inch,
Mm. 6 feet.
What?
Then 1 inch represent what? When we have 1 inch. So 1 inch This one represent what? Map or real?
6 feet.
This one, 1 inch, represent map or real?
Map.
Map, yes. And we have 6 feet, represent map or real?
Real.
Real. Okay, so in this question already he gave us the scale, right? Which is each 1 inch on the map represents 6 feet on reality. Then he back and said what? The length of an object of a scale drawing is 1.5 inches. Then now 1.5 represent map or real, ya Abdurrahman? Map or real? 1.5 inch. Map or real?
Real.
Inch. We said that 1 inch is map. Okay, and this one is real. Right? Then now he said 1.5 inch. Does this one represent map or real?
Map.
Map. Yes. So we will put the scale first. 1 inch over 6 feet equal 1.5 inch over x feet, because we are looking for the reality here. Right? We are looking for the real. Then second, what we have to do? Rahma, where are you? Rahma? Marwa? What we have to do to find the value of x? We are going to make cross product. So it will be x multiplied by 1 and then 6 multiplied by 1.5. Then the value of x equal 9. So the actual length, it will be equal 9. Then again, today we studied the scale drawing, and we said that the scale drawing represents the relation between scale length or actual length, or we can say map length or over actual length. Okay, next. The length of an object on a scale drawing is 4 centimeter and its actual length is 12 meter. The scale is 1 centimeter to how many? Where is the scale here? The length of an object of a scale drawing 4 centimeter and the actual length is 12 meter. What is the relation? Where is the scale? Where is the scale? Grade 7. Grade 7, where is the scale? The length of an object of a scale drawing is 4 centimeter. Well, actual is 12 meter. Then we will go to search. He said 4 centimeter and he said 12 meter. So where is the scale? It should be what? Should be what? 4, grade 7. 4 over 12. Should be what again? 4 centimeter to 12 centimeter. We are looking for each one. So we will make cross product like the previous question to find the answer. So in our lesson today, we were talking about similar figure, which they have same shape and different size. And we started scale drawing, which is the relation between map to real. For any question, for any question, is there any, who can tell me the relation between the scale drawing? It will be what? The relation between the scale drawing, it will be